Hi, good evening. It's Jim from Avstar. I know it's been a while, guys, since you saw the face behind the voice, so I thought I'd do a video for you where you could see me talking and we could talk about a few things. First thing is, guys, I don't want you to be concerned about donating money to me on the link down below. If you want to become a subscriber, it's entirely up to you, but we're not going to put pressure on people because obviously we have realised that people are struggling, and this is a global anomaly, and this is also something a friend that said to me would never happen, and yet it has, because you might expect one country to experience financial difficulties, but you wouldn't expect the world to experience financial difficulties, and that is exactly what's happening. You only need to look around at what's going on. I subscribed to somebody in Austria in Europe, and I was shocked because it's only when something that's close to your heart that you realise is going bankrupt, like KTM, which is the manufacturers that do produce those awesome motocross bikes, or dirt bikes as some might say. It's gone into bankruptcy over the last few days. That's incredible. They produce an awesome bit of kit which is equally as good as any other dirt bike in that range, like the RMs, the CFRs, the KXs. It is exactly competitive with all those, and it's like I say, it's an awesome company, and I've even had hands on using their products, like their dirt bikes, and I know they're good. So to hear a company like that going bankrupt is like, what? But we shouldn't be surprised. Moving to a different part of Europe, let's look at Germany. Volkswagen, Mercedes, Audis, they're good cars. That they're very popular with people, and they're cutting shifts, so it's not looking good. I put it down to largely green policies and the cost of energy right now. The other day I showed the National Grid here in the UK producing 11.5% energy using wind turbines. There wasn't no solar at that point in time being created, and it was relying on about 60 odd percent, I think 68%, 69% of gas, which produces CO2, and yet they wanted us to convert everything over to renewables by 2030. Well, we've been at this game for the last 15-20 years, and all we could produce was 11% of what the actual demand was needed, and we're failing, and there's no way on this time scale by 2030 we are going to meet net zero for zero emissions. But why should we anyhow? Look at China opening up a new coal power plant every month. Why don't Extinction Rebellion superglue their hands to the Chinese embassy in the UK, as opposed to the roads where people are just trying to get to work and earn a living? Instead of supergluing their hands to the roads and the runways and threatening to close down airports, why don't they do the right thing? If they've got any mentality and they've got a bit of logic, common sense, go and superglue their hands to the Chinese embassy. Because if they're worried about carbon going into the atmosphere, then one of the most prolific countries that produce it is China. It just doesn't make any sense in any case. It's all a load of lies anyhow. You don't have to take it from me. I'm just a humble scientist, a humble British scientist in the UK that probably, for the majority of you armchair, argumentative people, not qualified enough to talk about the subjects that I do. Certainly in YouTube's standpoint, I'm not qualified enough, even though I've got qualifications in natural sciences, which covers biology. Not qualified enough to even remotely touch on the subject of virology, because they don't like it when I do talk about that. And I think proof of the pudding is when I have talked about that, you've seen what's happened to my channel. It got demonetized. We've reapplied and removed those videos that they said was harmful content and medical misinformation they used. That was their term. We removed the videos. They still won't remonetize us. So, you know, you feel like it, don't you? So, you know, sometimes you just get wound up by the system that we're in, and you know, it doesn't make any sense. And, you know, we are where we are. Anyhow, I've been trying to do something about the situation with my central heating system. I want to make it a little bit more efficient, and I've been taking temperature of the radiators. You know, they don't seem to get hotter than 70 degrees Celsius yet. Even when they're at the maximum temperature, they're still relying on the fact that the central heating system is running. So I thought to myself, well, if that can't get no hotter than 70 degrees, or very little more than 70 degrees, why don't I shut that central heating system off, regardless of whether the thermostat is saying that the room temperature is at 21 degrees. So what have I done? I've come up with this. I don't know, I'll show you as best I can. I'm quite proud of that breadboard layout. I do put a little bit of time and effort in getting it as neat as I can, because if you see other people's breadboards when they're doing, you know, electronics, this is a massive, like, pubic hair of wires everywhere, and I just like to take a little bit of time crimping the wires to the right length and then putting them on the breadboard. And what we've got here is a temperature sensor, a DH11 I think, and a OLED, which is the screen reading the temperature, humidity and the heat index. And then we've got this Arduino Uno breakout board, which is controlling it all. And this is what I mean about programming. You know, I'm by all means and not an expert on programming and building electronics, but I have got to a certain level where I can build electronics that can communicate over 1 kilometer using TX-RXs. So, you know, I'm not the worst, I'm not the best, I'm somewhere in between. And even I make silly mistakes when programming the breakout boards or the Arduinos. And my big mistake this week, which cost me a day of scratching my head, replacing the thermometers, you know, the thermostats that are measuring the temperature, replacing those, thinking that they were broken, even though they were brand new, and various other things. And, you know, then I just done the simplest thing. I went over the basics and realised that the pin out for the thermometer was on pin 5, but I'd actually got it plugged in on pin 2 on the digital output on there. Simple mistake like that cost me a whole day, and that's just programming for you. You know, it could be simple fact that you've missed the dot out, but the good thing about when you're compiling your program up to the Arduino, there's a problem, it'll spot it and it'll highlight where the problem is, and then it's just a case of correcting it. So if you've missed the dot out, or, you know, you've put the incorrect input in there, it will highlight that line. Now sometimes if you're compiling for the first time, you know, you might put that right, and then you'll compile it again and it will say there's another problem and another problem and another problem. And that's the problem with programming. You know, you just have to have things nailed down tight for it to work, otherwise it just won't work. And that could be for a lot of reasons. It could be that on your breadboard you just don't have one of those wires that are coming off your live and earth to the components connected well. You know, there could be just a very bad connection there. It's not going to work because of that. Or you could have it in the wrong pins, or, you know, you might have the correct libraries, or you might have a library missing. So in this case, you've got a library for the text, you've got a library for the OLED, you've got a library for the actual thermometer. This particular thermometer is just a cheap one. I thought I'd buy a couple of those and do what I need to get it running, because then all I've got to do is rub out DH11 and put DH22 or 12, I'm not sure now. But the difference between the two thermometers, one's white, one's blue. This one that I've got has got a accuracy level to, I think, plus or minus 2 degrees Celsius. and the other one's got an accuracy level to plus or minus 0.5 degrees Celsius. But it doesn't really matter whether I use that type of thermometer or I go for thermocoupling, which I think I will do. Thermocouplings are like cylinders, and you can I think I've got one over there, I'll just show you. So this here is a thermocouple, and that's what I'm going to put on the radiator. Why am I doing this? Okay, so my radiator gets to 70 degrees, doesn't seem to get any hotter than that yet. The central heating system's still on, it works like a switch until it gets the room temperature of where the thermostat is up to that temperature. Then it'll shut the central heating system off. So my thermostat is fixed position and is not working efficiently. Now I know that there are thermostats on the market that are wireless, and wherever you can basically put them in your pocket and walk around the house, and wherever you are, it will get that room temperature up to that temperature. But your central heating will be also heating all the other rooms up as well, and some rooms will get to 21 degrees faster than the others because of the size, because of their airtight situation, whatever. There could be a lot of reasons for that. My point here is that I found out that if I let the radiator cool after it got to 70 degrees, I manually turned the thermostat off, and then 35 minutes later the temperature dropped down to 30 degrees on the actual radiator. So what I'm programming here is a pulse thermostat. It will override the thermostat. You can switch it off, so you can have it running normally, or you can have it running on the pulse program, which I'm building at the moment. And what that does is it just allows the radiator temperature to be the focal point, not the room temperature to be the focal point, as to whether the central heating system activates or not. So I will give it 35-minute intervals to cool down and allow that heat to, once it gets to 70 degrees, it ain't going to get no hotter, but it will allow that heat then to come down to 30 degrees, which will then be a heat transfer into the room. So yes, I understand it's going to take a little bit longer to get up to the required temperature, but once it gets to that required temperature, it's going to shut that central heating system off for at least 35 minutes. That means it will be at least 50% more efficient in the way it runs. Trust me on this. When I've finished the programming and building of these electronics, I will show you the outcome of this. I've done it with the old-fashioned, thermometer. Testing the radiator maximum temperature, switching it off, waiting a period of time for it to go to 30. At 30 degrees, it's still warm. You can put your hand on it. I'll give you, for instance, your bath temperature usually is around about 40 degrees, and that's a hot bath. So the radiator is still hot and it's still lurching out heat into your room, but we're not letting it go freezing cold, we're just letting it go to 30 degrees. And then I could have written a real complex program to run the thermostat. I'm not going to bother. I just thought, I know the time it requires to get down to 30% for me, so I'll just let it do that. So 35 minutes delay, which is one line of code. I'll just put, once you get to this temperature, delay for 35 minutes, and then it'll just keep repeating that cycle in the program over and over again until I say I'll switch it off at the switch, and I'll knock off the power of this, and it will just divert it back over to the normal thermostat. So that's what I'm building, and what I'll do with this is something I don't normally do. I'll give you the program, I'll give you the pinout of the Arduino and all the electronics that necessarily you need to buy, the relay and all that, because this runs on between 3.6 volt and 5 volts. Your thermostat, well, mine in particular, runs on 20 volts, so you need a relay. So we can use the Arduino to trigger the relay at 70 degrees. It will then bring the points together and shut the central heating system off. And then when it gets to 35 minutes later, the Arduino comes back to life, it will open the relay, the central heating system will come on. Actually, the reverse, it will close the relay, the central heating system will come back on. When it gets to 70 degrees, it will open the relay, removing the points or the core for heat from the central heating system, and it will just keep doing that in a cycle. So that's what we're going to do with that. And if you're interested in possibly saving, you know, a good 50% of your energy for heating your home this winter, then just stay tuned. I haven't got the money to, once I've finished building all this and proving it, I haven't got the money to take it to the next step, which would be manufacturing. Then the next step from there, once we've got it manufactured, because I believe this device could be manufactured for as little as less than £10. Yeah, but I haven't got the money to get it to that level. I certainly don't have the money to bring it to market as well, other than just through word of mouth with you guys. That's if you wanted to, you know, to use it. But do it yourself. Do this test. Get your room that you're in, or get the radiator as hot as it will get, usually around about 70 degrees Celsius. Once it's at that temperature, it ain't going to get no hotter, no matter how much your central heating system works. What your central heating system's doing is relying on where the thermostat is, and mine couldn't be in a worse place, because if you go down the stairs in this property, there's a thermocline. You can naturally feel the coolness of it downstairs as opposed to being at the top of the stairs. So, you know, most of my heat is just being sucked out downstairs in this property. And as a result, you know, the thermostat that's in the hallway leading onto the stairs is in the wrong place. But this will correct it anyhow. So this will get the room that I put the thermostat onto, the pulse thermostat, directly onto the radiator. It will override the thermostat in the wrong place, and therefore make the central heating system much more efficient. And I know it's going to work, because if your system isn't on for 35 minutes, that's a 35-minute saving of gas that runs the central heating system. Anyhow, you know what? I won't keep you any longer than what I have to, guys. You know, we're living in funny times. We really are. And there's a lot of things I wanted to talk to you guys about in this video, but I don't want to keep you too long, because I know that, you know, your time's better spent with your family, but also I know that it's important that you know, if you can pick up a bit of information from here and there, then that's good. So, you know, just off the topic that we've been on, I'm sure you've noticed a lot of office space around where you live, and a lot of commercial property not just being rented for a lot of reasons. And that probably stemmed from the pandemic, when everybody mostly had to work from home, and, you know, companies found that they could run the business that way, and therefore, you know, what is the point in having, you know, these office spaces, you know, where we pay rents, electricity and all the other bills on top, when people could work from home as efficient, and you know, we could save that money. Well, that's exactly what they're doing now. You know, they're called hybrid jobs, where you work from home most of the time, and you know, your company's probably inclined to pay your phone bill for you in order for you to do that, because, you know, they could pay the phone bill in the office, or they could pay at home for you. If they pay you your phone bill and your time, they was paying your time in any case. The only extra they're going to pay now is the phone bill for you to communicate with your clients, as you was when you was in the office. The only difference is they're saving money. But is the problem, because these companies that borrowed money to develop these office buildings, or took over them, they borrowed money on that, and that has now gone back to the bank as possibly a receivership. You know, that company that was renting that space out to your company has gone bankrupt. So the book's gone back to the bank, and they're holding negative assets now that they can't rent out. That means that banks are going to go bankrupt. I think we might see the same as what we saw back in 2008, where they're going to load up one or two banks this time with bad debt and then collapse the bank, in order to avoid paying that most of the losses. But it still doesn't resolve the problem of these empty offices being there unrentable. It just resolves the loss of money that was borrowed on them, because they're going to go down in value, just like people's properties are now. I said to people, if they sold the property last year and brought a small holding somewhere, they would be 10% better off now if they did that. Now, they're trying to sell it in a more competitive market because more people are trying to sell the properties. There's properties over the road from where I live right now that's almost been up for sale for a good 9 months, still up for sale. So it's not a seller's market right now, and this is only going to get worse and worse. And the more that goes back to the banking, back negative business, is just going to pile up and pile up and pile up until something really bad happens. And of course, we shouldn't expect anything less. We've got artificial intelligence, we've got mechanisation that we've never had or seen before in the industrial workspace, which is doing away with public labour, so that less and less people are required for work. But what does that do? Well, if less and less people haven't got money, then the government's GDP will shrink as a result of that, and that'll mean more borrowing from the government, which will mean more further insolvency. This problem doesn't get any better. When we look at the things that have been targeted under the green policies, now more so than ever, we move to the agricultural industry, farmers, for instance. They're the ones that are copping the brunt of this now. They're being targeted heavily, and they shouldn't be at this time, because when we look at the arable land that is capable of growing food on to feed the world, they're targeting it. And if it's not going offline through nature itself, through things related to the magnetic pole reversal, etc., 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 working its way down to that land is no longer able to grow the crops because the seasons aren't the same, don't sustain the growth that crop needs, then all we see is further arable cropland go offline, and then further arable cropland go offline because farmers can't afford to farm their own fields because of all the penalisations due to cow farts and whatever. I could be more technical, but I think you get where I'm coming from with this. It's just going crazy right now. We're doing all the wrong things as opposed to doing all the right things, and as a result, the outlook is more dismal than it ever has been. So, we'll stand up again here at the Observatory. We say don't worry about the PayPal link down there. I'd rather you buy some rice, some pasta for your family, and if you can afford, support us on Patreon. Simple as that. And we have the utmost respect, and we couldn't thank those guys anymore that have stood with us on Patreon as long as they have, because without them we wouldn't be in business now doing what we're doing. And let's face it, what do? We're the only ones that talk about the magnetic pole shift that have actual equipment monitoring it. We're the only ones that go out there, take CO2 readings. We are taking readings of muons because that is what's on the increase if we get more collisions in the upper atmosphere with cosmic particles inbound through a weakened magnetosphere. And a lot of other things that we monitor, like background radiation. Of course, that will go up. Gamma, beta and alpha particles will go up, and we'll be able to detect that as we monitor it. Oxygen levels, we monitor that as well. So we monitor the magnetosphere with the magnetometers, the muon detector. We're monitoring the fragmented particles as they come through the atmosphere and destroy into small subatomic particles, CO2, oxygen, and the position of the magnetic North Pole. All the others talk about it, we actually build it and do it. You know, we're into this, which is walking the walk and not just talking the talk. And that they cannot do that, other websites. They have to rely on government regurgitated nonsense. And I just want to ask you the question, do you really trust governments to inform you at this point in time where we are at now? Let alone 5 years ago, but what about now? I think you would agree more so now that you can't trust them. You can't trust mainstream media because it focuses on what the script is as opposed to what the situation is. And having said that, I think it's time we wrap it up here, guys. You know, it's been nice to do a video like this for you guys so you get to see the face behind the voice. And I suppose the only other thing to say at this point is you take care of your loved ones, as always. Bye for now.